Have you ever wondered what's actually happening when your phone says it has 128 GB of storage, or when someone talks about downloading a 5 MB file? Today, we're going on a journey through every storage unit that exists in computing, from the tiniest bit all the way up to units so massive they sound like science fiction. Let's start at the absolute beginning, the bit. This is the smallest unit of data in computing. A bit can only be one of two values, 0 or 1. That's it. Think of it like a light switch. It's either on or off. A single bit by itself can represent whether something is true or false, yes or no, on or off. Everything in your computer, from the video you're watching right now to the most complex AI, is ultimately just billions and billions of these tiny on-off switches working together. Nibble or nibble. A nibble is exactly 4 bits, which is half a byte. Nibbles are actually super useful in computing. They're commonly used in hexadecimal numbers. One nibble can represent 16 different values, from 0 to 15, which corresponds perfectly to the hexadecimal digits 0 to 9 and A to F. When you see a color code in web design, each pair of characters represents one nibble of information for red, green, and blue values. Byte. A byte is 8 bits, and this is the fundamental unit that most computer systems use. With 8 bits, you can represent 256 different values. This is why a byte can store one character of text, like the letter A, a number, or a symbol. Think of a byte as a single letter in a book. Just as letters combine to form words, bytes combine to form files, programs, and everything digital. The word hello takes up 5 bytes of storage, 1 byte per character. Kilobyte or KB. A kilobyte is 1024 bytes. Wait, why 1024 and not 1000? Because computers work in binary, base 2, and 2 power 10 equals 1024. However, some manufacturers use 1000 bytes for marketing purposes, which causes confusion. A plain text email with no attachments typically takes up about 2 to 5 kilobytes. A low-resolution icon or emoji might be 5 to 10 kilobytes. A single page of text is usually around 10 kilobytes. Think of a kilobyte like a single page in a book. It's not much, but it's enough to convey meaningful information. Now let me tell you something absolutely mind-blowing. The Apollo 11 guidance computer, the computer that helped land humans on the moon in 1969, had only 64 kilobytes of memory and 72 kilobytes of read-only memory. That's right, NASA sent astronauts to the moon with less computing power than a modern calculator or a cheap digital watch. Megabyte or MB. A megabyte is 1024 kilobytes, or roughly 1 million bytes. This is where things start getting more familiar. Most of the files you interact with daily are measured in megabytes. A high-quality photo from your phone typically takes up 3 to 5 megabytes. 1 minute of MP3 music is about 1 megabyte. A typical ebook might be 1 to 2 megabytes, and an average song on Spotify is around 3 to 4 megabytes. If a byte is a single letter, a megabyte is like an entire novel. You're now dealing with substantial amounts of information that can contain complex images, minutes of audio, or thousands of pages of text. The shift from kilobytes to megabytes represented a massive leap in what computers could do, because suddenly they had enough space to store not just text and simple graphics, but rich media. The floppy disk, which many of you might remember or at least have seen as the save icon, went through several iterations. The 3.5-inch floppy disk that became standard in the 1980s and 1990s held 1.44 megabytes. This was considered revolutionary at the time. A gigabyte is 1024 megabytes, or about 1 billion bytes. This is the unit you see most often in 2025. Your phone storage, computer RAM, and most modern files are measured in gigabytes. A movie in standard definition might be 1 to 2 gigabytes. A high-quality HD movie could be 4 to 8 gigabytes. A modern smartphone app can range from 50 megabytes to several gigabytes. A AAA video game today typically ranges from 50 to 150 gigabytes. Your phone storage options are usually 64, 128, 256 gigabytes or more. If a megabyte is a novel, a gigabyte is an entire library shelf packed with books. A 128 gigabyte phone can hold roughly 128,000 novels worth of text, or about 30,000 high-quality photos, or approximately 32,000 songs. Terabyte or TB. A terabyte is 1024 gigabytes, or about 1 trillion bytes. We're now in the realm of external hard drives, professional storage, and data centers. A standard external hard drive today typically holds 1 to 5 terabytes. Your entire Netflix viewing history over several years might total up to 1 terabyte of data. A terabyte could store about 250,000 photos, or roughly 500 hours of HD video. The entire print collection of the United States Library of Congress is estimated at about 10 terabytes when converted to digital format. Imagine a terabyte as an entire city library with thousands of books on countless shelves. Most regular consumers don't need more than a few terabytes of storage for personal use, but businesses, content creators, and professionals who work with video and high-resolution imagery easily deal in terabytes daily. A professional photographer might shoot a single wedding and come home with 100 gigabytes of raw photos. A videographer shooting in 4K might fill a terabyte in just a few days of filming. The Hubble Space Telescope generates approximately 120 gigabytes of data every week. The Large Hadron Collider, the world's largest particle physics experiment, generates approximately 1 petabyte of data every second when it's running at full capacity, petabyte or PB. A petabyte is 1,024 terabytes, or about 1 quadrillion bytes. Now we're getting into serious territory. Individual consumers never deal with petabytes directly, but large companies and research institutions certainly do. Google processes approximately 20 petabytes of data per day across its various services, including Search, Gmail, YouTube, and Maps. Facebook stores hundreds of petabytes of photos and videos uploaded by its billions of users. All of the written works in human history, every book, scroll, manuscript, and document ever created, is estimated at 50 to 100 petabytes when digitized. If you wanted to store 1 petabyte on DVDs, you would need about 223,000 DVDs. If you stacked them on top of each other, that tower would be over 900 feet tall, which is taller than most skyscrapers. Exabyte or EB. An exabyte is 1,024 petabytes, or about 1 quintillion bytes. This is where we measure the entire internet and global data generation. Global internet traffic is approximately 150 to 200 exabytes per month as of 2024, and this number keeps growing exponentially. All words ever spoken by humans throughout history are estimated to equal about 5 exabytes of data if you converted them all to text. Google's total data storage across all its data centers worldwide is estimated at several hundred exabytes. YouTube's total video storage is estimated at 1 to 2 exabytes, and growing every single day as creators upload 500 hours of new video every minute. An exabyte could store approximately 250 million DVDs worth of data. If you watched all that content back to back without sleeping, eating, or taking any breaks whatsoever, it would take over 50,000 years to get through it all. That's longer than recorded human civilization has existed. You could start watching before humans invented writing and still not be finished today. Zettabyte or ZB. A zettabyte is 1,024 exabytes, or about 1 sextillion bytes. We're now measuring the world's total data creation and storage. The total amount of digital data created and stored globally in 2024 is estimated at 120 to 150 zettabytes. By 2025, the global datasphere is projected to grow to 175 zettabytes. This includes everything. All the data in all the data centers, all the information on all the computers, phones, and IoT devices, every video ever uploaded, every photo ever taken with a digital camera, all scientific data, business records, medical records, everything. All the data on the internet as of 2024 represents approximately 64 zettabytes of information. To put this in perspective, if you stored 1 zettabyte on 1 terabyte hard drives and lined them up end to end, they would circle the Earth over 100 times. If you stacked them vertically, the tower would reach from Earth past the moon and continue for millions of miles into space. Yottabyte or YB. A yottabyte is 1,024 zettabytes, or about 1 septillion bytes. This is as far as the official naming system currently goes, and honestly, we don't even have practical applications for yottabytes yet. The entire digital universe as of 2025 hasn't even reached 1 yottabyte yet, though we're getting closer every year. A yottabyte could store approximately 250 trillion DVDs. If you had a yottabyte of storage and filled it entirely with HD movies, you would have enough content to watch continuously for over 200 million years without ever seeing the same thing twice. If a byte is a grain of sand on a beach, a yottabyte would be like all the beaches on Earth combined, then multiplied by 10,000. It's a number so large that it becomes abstract. Our brains simply aren't wired to truly comprehend quantities this enormous. Even most scientists and engineers work with these numbers purely mathematically because there's no intuitive way to grasp them. Technically, the officially recognized units stop at yottabyte according to the International System of Units. However, computer scientists and enthusiasts have proposed names for even larger units following the same pattern. These are mostly theoretical, not standardized, and rarely used in any serious context, but they're fascinating to think about. The next unit would be the brontobyte, equal to 124 yottabytes. The name comes from the Greek word for thunder, though some people jokingly suggest it's named after the Brontosaurus, one of the largest dinosaurs. Nothing on Earth currently uses this unit. It's purely theoretical. We would need to see multiple orders of magnitude growth in data creation before a brontobyte becomes relevant. After that comes the geobyte, equal to 1,024 brontobytes. At this point, we're talking about amounts of data that might be needed to simulate entire universes, store information at quantum scales, or represent concepts we haven't even imagined yet. Various sources on the internet list additional units beyond these with names like Saganbyte, supposedly named after Carl Sagan and his famous phrase, billions and billions. Then there's Pigabyte, Alphabyte, Cryotbyte, Amosbyte, Pectralbyte, Bulgerbyte, Sambabyte, and Quisabyte. However, and this is important to understand, these larger units are not officially recognized by any scientific or computing standards body. They're more internet folklore and playful speculation than actual computing terms. The scientific community generally stops at Yottabytes because we simply don't need anything larger yet, and creating official names for units we might not use for centuries or millennia seems premature.